Before you begin, lab safety starts before we're even into our lab. The first step of being safe in our chemistry lab is that you read through what we are going to do the day before. You all got a syllabus of what is going to happen each week in class. Before class, you need to make sure you read through what we are going to do that day. And then, the next part of this is if you have any questions or concerns, you need to make sure you ask. So, today, there was nothing on your syllabus about doing a lab demonstration that you guys could repeat at home, but it is not anything that is with toxic chemicals. We are going to use some vinegar, some pennies, and some water. But if we were doing a real lab today, my expectation would be for you to read the lab in the lab kit and think about it before class. That way, if you had any questions, we could go over them. Even though we're not in a proper, quote-unquote, lab, and I cannot see you, my expectation is that you are behaving properly in the lab. You should never horse around or behave in any way that could lead to you to injure yourself or someone else's to become injured. When you are getting ready for a lab, there are a few things that you should keep in mind. First, we are going to wear goggles in all of our labs. There are safety goggles that come with your lab kit. If you have different safety goggles, you may wear them. However, you need to have something covering your eyes. Glasses do not work unless they have side lenses, like sports glasses or safety glasses. Regular glasses do not work. In chemistry lab, there is the risk that you will break a glass, a test tube, that something will spill on you. Good lab procedure is that you wear shoes and socks, not bare feet, and that your body is covered. For example, when we are doing labs, I will wear a long sleeve shirt so I do not get chemicals on my arms. I will wear pants so I do not get chemicals on my legs. I also want you guys to think about where you're doing your labs. Now, the other day, I did class in my office. However, I am not comfortable doing labs in my office because I do not want to spill on the rug on the floor. So I will be doing my labs most often in my kitchen or at my table. I cover the table with a tablecloth with paper so that if anything does get on it, I just clean it up, throw it in the trash can. I would suggest that you not do your labs where you are going to then sit down and eat your lunch. Put something over the table, even if it's just a placemat, some leftover newspaper that you can throw away. You should always know where the nearest water source is. For example, if you get chemicals on your hands, on your face, in your eyes, you need to be able to rinse off quickly. You don't want to be searching for it, which is another reason why I do my labs near the kitchen sink. Some safe lab practices. When you're looking in a test tube, you should be holding the test tube up like the man in the picture and looking at the contents from the side of the test tube. And I'll show you with this beaker. You're going to hold it and you're going to look like this. So you're kind of looking through the beaker. You're never going to look at something like this, up like straight down, because if something were to bubble up, if a explosion were to happen, it's going to go right into your face. You don't want that. If you are heating test tubes, you always point them away from you and away from others in case the heat causes a reaction to occur. You are never going to eat anything that we make or that you use in your chemistry lab. And you should not be eating, drinking, or chewing gum while you are actively doing a lab. If you are asked to smell something in the lab, which there is one lab where it asks you if there's any odor, you don't go like this to smell it. you are going to take your test tube and hold it a distance from your body, and you are going to use your hand to move any sort of fumes towards your nose. It's called fanning the fumes. In the event of an accident, you need to let two people know. You need to let me know, either in class or in an email after class, and you need to let someone at home know, your mom, your dad, whoever is there with you. For two reasons. One, I want to make sure that our lab is safe and we are doing the best that we can at Bridgeway to make you guys safe. And you need to let someone at home know so that they can make sure everything is okay. If you get burned, if you spill something on you, just let two people know, me and someone at home. If you get any sort of chemical in your eye, or you think you have anything in your eye, you don't have an eye wash fountain at home, you are going to just take your eye, open it up, and run it underneath your kitchen sink or your bathtub, whatever. Or you can take a cup and put it over your eye like that and keep blinking. At the end of our lab, we're going to do a cleanup. Most times, we're not going to do this as part of our class. You're going to have to clean up on your own after class time, so we're not wasting time. However, there are a few labs where if we don't clean up right away, the residue will stain the glassware. So I will tell you when those labs are taking place. You're going to clean all the glassware off, clean it with fresh water a couple of times, let it dry. Once it's dry, you're going to turn it to the lab kit because you will be using it again for other labs. If it's something we're going to throw away, I will tell you, go ahead and throw away the cotton swabs we throw away. Some of the chromatography paper we'll throw away. But all of the chemicals, all of the glassware, all of the pipettes, we will wash after each class, dry them off, put them back in the shoebox until next week. Do you guys have any questions about lab safety? All right, fair enough. I did not think that you guys would. Okay, one of the important things in chemistry lab is just knowing what chemistry is, what the scientific method is, and learning about observations. So we are going to take a minute, and I unlocked your whiteboard, and I'd like you to go ahead and make some observations about the room you are sitting in. So I'd like you to make 5 observations about the room you are in. And go ahead and put them up on the whiteboard. Remember, you can make the whiteboard screen large if you want. Okay, is someone having a hard time writing on the whiteboard? Okay, perfect. So we have some good observations you guys made about your rooms are the only one here. The windows are open. The lights are turned off. It's warm. There's plenty of shadows. Those are all great observations. The room is square. There's artificial light supplied by the ceiling fan. There's a closet full of shirts. There are lots of binders, and the walls are white. And I made my observations as well. We all made those observations basically using our sense of sight. As we go through this chemistry course, we're going to talk about our different senses and what we do and don't do and how we use our senses. The most important sense for us is our sense of sight. Now, none of us wrote what our room smells like or what the air in our room tastes like. Okay, so as you're making observations, be sure that you talk about all of your senses. If I was going to make another observation using my sense of smell, I might say, my room smells, like cookies, because I just baked some cookies. Okay, that's also an observation, just using a different sense. So go ahead and each of you make an observation about using a different sense, either a sense of smell, sense of taste, which is hard to observe the room you're in with a sense of taste. There's another observation you can make. Go ahead and put it up on the whiteboard. I love it. The room smells like plumerias and the sounds of chickens can be heard. Great job using your other senses. Perfect. Now in chemistry class, we are going to use our senses. And one of the ways we are going to also get through this course is by using the scientific method. So I just went ahead and released another PowerPoint to you called What is the Scientific Method? We should be able to go through this pretty quickly. What is the scientific method? Can either of you give me a description of the scientific method? Go ahead and raise your hand, and then you can go ahead and talk it out. Any ideas? What is the scientific method? Oh, that's all right. Well, I'm sure you both have heard of the scientific method before, and I do know that it's very early where you both are. But what is the scientific method? The scientific method is a way that scientists, or a way that we, are going to ask and answer questions by making observations, like we just did, and doing experiments. Now, the experiment that you are going to do today, or for homework this week, is an experiment where I'm going to give you the guidelines, and you guys are going to create your own very simple experiment. And we're going to walk through a couple of experiments that you could do today. As we move through the chemistry lab, the experiments that you do are going to be much more structured due to the nature of the materials that we are going to be using. There's several steps to the scientific method. Now, as a scientist, you can start at any point in this method. We are going to start at the top in almost every instance. The first way to start the scientific method is to ask a question. So we need to think about a question. Today, our question is going to be how to clean a penny. We're going to do some background research. Then you are going to construct a hypothesis. A hypothesis is an if-then statement. If this happens, then this is going to happen. Or I think this is going to happen if this happens. You're going to test it with an experiment. You are going to come up with something to do. You are going to analyze the results and draw conclusions. From your results, you are going to say, ooh, my hypothesis was true, or no, I was totally wrong and I need to come up with a new hypothesis. If your hypothesis was wrong, you're going to go back up and make a new hypothesis and try to come up with a new experiment to test that hypothesis. Once you come up with a hypothesis that is true, you're going to report your results. So we're going to walk through this. And we're going to walk through this with the question, why are there more great white sharks close to land? This is our question. I don't know the answer, but I'd like to try to figure it out. So I'm going to do a little bit of background research. I'm going to look at any previous studies, which there are some. I just don't know if I believe them. I'm going to do research on great white sharks. What do they like? What type of habitat? What do they like to eat? I'm going to do research on the prey and predators of great white sharks. Then I'm going to make a hypothesis. Based on my research, I'm going to make my best guess to answer my question of why they come close to the shore. So my hypothesis may be different than your hypothesis, and that's okay. When we do our labs, as long as your hypothesis makes sense to you, that is fine. So my hypothesis is great white sharks come close to land to eat. Now we need to come up with an experiment to test this. Now, as I said before, our experiments in class are going to be written out for us most of the time. This experiment I am going to come up on my own. So my experiment is I'm going to set up an experiment that monitors the activities of great white sharks close to land. I'm going to use video cameras and tracking devices to figure this out. I'm going to run my experiment, let's say, for 3 weeks. Then I'm going to look at all my data from the tracking devices and from my observations. So as you see here, I have a pie graph I made, I have a bar graph, I have a line graph, and then I have a data table. How you organize your data is going to be different for each lab. I'll give you suggestions, however. We're going to then draw conclusions. So my conclusion is that great white sharks come close to land to follow prey like seals. That's based on my data, based on my observations. So was my hypothesis true or false? This time it was true. Most times your hypothesis is going to be false. Even the best scientists come up with false hypotheses often. Now, to report my results, we are going to write a scientific paper explaining my results. Now, when I write my scientific paper, for this class, it's going to be in the form of a lab report. If I was actually writing a scientific paper, it would be a written scientific paper. Which leads us to our next topic, writing a lab report. If you went into if you went into Moodle, which I know both of you did because I saw your answers to the orientation assignment, so I know you've both been in there. There was, if you took a minute to look around, something that said lab reports. That gave us an idea of how we are going to write lab reports for this class. Now the great thing is, lab reports can be different depending on who you are writing them for. I put the lab report guide right here so that you will have an idea of what I would like. Because everyone is different, but I want you to know what I am looking for. When you write a lab report for me, I am looking for 2 pages. And I'm going to put it down here. I'm going to put it up in the whiteboard so we can go ahead and take a look at it. I'm going to delete everything that we have up here already. You may want to make your PowerPoint large, or your whiteboard larger so we can see it. We are going to have a title page. On the title page, this didn't format very good. On your title page, you are going to put your name, title of the lab, my name, and the date of the experiment. That's it. That's all you are going to have up on that. On that page. Then you are going to go to the next page. On the next page, you're going to have the title. The title is going to describe the main point of your lab. You can use the title that's in the book if you want. That's what I would do. Next, you are going to have an introduction. Your introduction is going to be 1 paragraph. I don't know why it's formatted like this. 1 paragraph that explains the objectives or purpose of your lab. You're going to actually label this introduction. Then you are going to have materials. Materials is going to be easy. It's going to be just a list of everything you need to complete the experiment. Then you are going to have your methods. Your methods are going to describe the steps of your lab. The methods, in my opinion, is the most important part of the lab. Because if you don't have a good method, someone will not be able to repeat your experiment. And the point of doing a lab or an experiment is that it's so detailed that I could repeat it. So when you turn a lab into me, I should be able to hand it to my 10-year-old son, and he should be able to do the exact same thing you did and get the exact same results you got. If he can't figure it out based on what you wrote in your methods, then your methods are not written well. When I write a lab report, what I do is I go ahead and I write my methods section, and then the next day I go back and I reread my methods section, and I see if I can answer or do the lab again. If I can, then I have a good method section. If I cannot, I do not have a good method section. After the methods section, you are going to put your data. This could be in the form of a data table. It could be in the form of a chart or a graph. It could be in the form of pictures. It could be in the form of a paragraph. All depends on what your data was. In most cases in this course, it's going to be either a data table or a graph. Then you are going to put your results. So you're going to describe in words what the data tells me. You are going to do your discussion. This is where the data is interpreted. Was your hypothesis correct? Yes, my hypothesis was correct. No, it was not. And then you're going to do your conclusion, a paragraph that sums up your experiment. Now then on the bottom I have figures. If you have figures that you did not put in your data section, let's say you made a data table, but then you really liked a graph, so you want the graph in your lab report too, you're going to put that down here. And the more information that you add, the better. Because that is just going to give whoever is reading your lab report a better idea of what happened during your lab. This is the format you are going to use for the entire course. Any questions about the format of our lab reports? You guys are awfully quiet today. This format is right in the Moodle site. It's called, I think it's called Lab Report Format. Right there for you to see in the very top section. You can refer back to it at any point in the class. Now, one of the other things that we're going to do a lot in this class is we are going to graph things. We're going to go ahead and look at a graphing PowerPoint. I think that you guys are probably going to be comfortable with graphing. So we're just going to go through this real quick to make sure. So you should see a PowerPoint now, so make the whiteboard screen smaller. It says graphing. Why do we graph data? We need to graph data so that we can give a picture of what is happening. We show a picture of numbers. So this graph is showing me the total number of beans, peas, and squash plants over a 4-week period. It's giving me a picture. There's a couple of important parts of a graph. These parts are parts that you should have in every graph you make, whether it's a bar graph, a line graph, a pie graph. That is not important. You need to have a title located at the top. This one's title is Total Plants. You should have an axis title. I have an title on my vertical axis that says number of plants, but I do not have one on my horizontal axis. So what am I looking at? It says week 1, week 2, week 3, week 4. Weeks of what? Okay, you need to add a title so you know what you are looking at. This graph has a key. Blue is beans, red is peas, and orange is squash. That's what we are looking at. Are we looking at plants? Are we looking at pets people have at home? I don't know unless you give me that information. And then we need to have the data. We need to have the numbers. What on earth is going on in this graph? There's 3 types of graphs that we will use. We are going to use line graphs the most. Line graphs are used mostly to compare 2 things when the data is a quantity that varies with time. Plant height versus the number of weeks. Temperature versus days. Temperature versus time of the day. A bar graph compares 2 things when you're not looking for a trend over a period of time. And a pie chart shows parts of a whole. Pie charts are most effective when you're only using a few parts. If you have 100 parts, a pie chart is not very effective because you can't see a big picture that way. So here's an example of a good line graph. I have my data over on the left-hand side. I added a picture here, and we are looking at the height of plants in the sun versus the shade. So the red line represents plants in the shade, and the blue line represents plants in the sun. The vertical axis is telling me heights in inches, and the horizontal axis is showing me days. I'm going to send a poll to you guys. Just kind of to see what you feel like you need help with. So go ahead and just answer yes or no. Are you comfortable making graphs? If I were to give you data, do you think you could come up with a graph, or is that something that you would like to go over? Okay. Then we're not going to go over it since you both said you're comfortable with it. Okay, so we're going to skip ahead a couple of things here. Oops. Okay, now here's an example of what you would use a bar graph for. We're not going to plot it together if you guys are comfortable with it. But the number of pets in a class where you have different pets, but it doesn't matter the amount of